So Debugging Debugging, I just wanted to clarify the title at the get-go here. The goal here is to help you understand how debugging works from the inside out, to debug debugging. And I hope you'll come out of this better able to diagnose and debug your own programs, and also able to give us some feedback in Node Core and the Diagnostics Working Group about some of these things and the way they're being implemented and how we can better serve you. So in this session, I'm going to take a couple minutes and just discuss the Diagnostics Working Group, its goals, and a couple things that we've done this year. Then I want to take you on a journey through demos of a couple evolving interfaces, inspector and tracing controller. And hopefully along the way, you'll learn some new tricks, learn some new tools, and be able to write some of your own script. As Julia already said, I'm Josh. I'm a technical PM working on open source at Microsoft for a while. I'm the coordinator / cat herder for the Diagnostics Working Group. Which takes us to what exactly is the Diagnostics Working Group. And the goal, this is really important. It's to let us all come together and create a bunch of open interfaces that developers can use directly, that can be built into open source projects, that can be built into commercial products, stuff that we can all party on so that we can have a great ecosystem of tools to better understand our apps. So definitely check out Node.js Diagnostics. The issue tracker there is where we have discussions. There's some documentation in the main repo. Also, there's some overlap. The Postmortem WG also has some diagnostic tools, so check them out too. Some diagnostics projects which have come through this year. Async hooks, or you might know it as async wrap, which has been designed to help share context or track callback registration and invocation. V8 Inspector from the V8 team, which provides a new API for understanding what's happening in V8. Node Inspect, which we're talking about bringing in as a new CLI debugger, which will work with the new Inspector API. A couple from the Postmortem WG, Node Report, which gives you a bunch of information about the state of your process if it crashes or on certain signals. LL Node is written, it's an extension to LLDB, which gives it better understanding of V8 JavaScript frames and objects. And then finally, the tracing controller, which is just a PR at this point, but it allows you to insert trace points throughout Node and get information in a log. Okay, so with that, let's dive into Inspector. One of the most exciting parts is it's the same protocol that Chromium has used for a while now. You've been able to use Node Inspector in the past, but that was kind of a hack. Translating from the Chromium protocol to the old debugger protocol. So now we have the same one as Chromium, step debugging, being able to jump into a running script and even modify it, and a couple new things that weren't possible with the old debug interface, heap analysis and CPU profiling. I want to take you through a journey of using that interface. Specifically, I want to start at the low level with WebSockets and HTTP and kind of show you how it works at the low level, show you a couple tools that you can use that are built on top of it, and then finally take you out to a high-level tool or two. So just to kind of orient you around what we're going to do here, here's a picture of kind of how the architecture looks. You've got Node over there on the right with V8, a big part of that. Your user script will be running in V8. Then there's an inspector agent which also runs alongside the main event loop in Node and exposes, at this point, a WebSocket interface. On the other side, I've made some concentric circles to kind of represent going from low level out to higher level. And that's actually the journey we'll take. We'll start with curl. We'll go through some command line tools and then show some graphical tools. Okay, so first thing I want to do here is actually set up a network trace, which will show you the incoming and outgoing WebSocket data, TCP source port, TCP dest port, text, sorry, this equals L, dash T fields. If I'm lucky, I'll have gotten that right. There we go, missed an R. Okay, so we have our network capture running. So you'll see some stuff over there. Now I'm going to go ahead and spin up a node process. Let me just show you the script I'm going to run. Node scratch index.js. It's pretty simple. It just spins up let's go down a little bit. Spins up a basic HTTP server and sends back received request number 1, number 2, number 3 as you go along. So we'll close that out. And we will just run that now. Node scratch index.js. And now I've got my HTTP server listening on port 8080. Actually, I also need to add the -- inspect command line flag. Okay, so we've got that node process running. It's waiting for requests. If I curl against the straight endpoint there, I should get back response number 1 received. I see on the console on the other side, request received. Let's show what the inspector gives us back. So if I curl against localhost 9229, that's the port that it's listening on by default. You'll see if I say nothing else, I get back WebSockets request was expected. It doesn't work, it's WebSockets. But there are a couple metadata endpoints. Actually 3 I want to show you. So one of them is list. So it's always whack JSON is the metadata, like the beginning of the metadata endpoint. So whack JSON, whack list will give you some important information amongst that this ID, which we're going to need later on. The other 2 are version, which tells you some information about the version you're talking to, and protocol, which actually gives you back the full schema of the protocol that this understands for inspector, which can be helpful if you want to dynamically use certain features. Okay, so we saw there how to curl against it using HTTP. Let's use WSCat. Shoot. NVS use 710. I think I have it installed somewhere else. Yeah. So WSCat is a tool which basically opens up a WebSocket connection, and you can type stuff in and get stuff back. So we're just going to go ahead and show exactly how that looks on the wire. Oh. Over here, I meant to show you guys some stuff as this was going on. I have to add one more thing here, -y WebSocket. Okay. Okay, so we do WSCat. We say connect to WS : localhost 9229. What did I do wrong there? Just look at my notes. Oh, no, okay, that's actually a good thing that I missed that, because that's an important detail. So every process is getting debugged gets its own UUID, its own identifier, and it won't allow you to connect unless you specify that in the string. So here, for example, the identifier is this. You can get it out of the output from when you run -- inspect. So now if I go back down here and I type WSCat that plus this UUID, then I actually connect. So that's an important thing to know. If you're building something on this, you got to first find out what UUID is being used for that process. Now I'm connected. I'm just going to go ahead quickly. I'm going to copy this out. One of the useful APIs, one of the useful protocols, that you can put in here is you can get a list of the domains that are supported by the current inspector instance that you're connected to. So here I'm actually just calling using JSON RPC. I specify that the method I'm going to use is schema get domains. And you actually can see, I get back, and you can see it on the other side too, the WebSocket protocol coming in on the network. And I get back the ones that are supported. So here's debugger is supported, runtime, heap profiler, profiler. You can find out more about these domains just by going to the Chrome debugger protocol. Just search for that online. There's the debugger protocol viewer. And you can get a list of the supported domains. So you'll notice that here's V8 inspector, and those are the bunch that I just saw. Okay, let's step it out a bit because I'm running out of time pretty fast. Let's take you to Chrome Remote Interface, which is a library intended to allow, it was originally built to interact with Chrome, but you can use it for Node also. You say Chrome Remote Interface inspect localhost 9229. What did I do there? Oh, yeah, maybe. Well, let me just check my notes again. Here we go. So we actually don't have to specify localhost, my mistake. Port 9229, and I specified -- remote. I'm actually going to blow this up a bit. That actually retrieves the protocol dynamically from that JSON protocol endpoint, and I have access now to all of the methods that are available from the Chrome debugging protocol right here in this REPL. So I could say like runtime enable, and actually if I zoom back down, you'll see I sent that over the wire to the inspector, and I get back whatever I'm supposed to get back there. This is actually really nice for programmatically getting information out of the process. So let me just show you another script that I have, which is cat .node inspect helpers. And this is called index. So it's a pretty simple script. It's called get CPU profile, and you specify how long you want it to run for, and it will actually, using this, using the Chrome Remote Interface, will actually call profiler, the profiler domain, enable, leave it on for 10 seconds, turn it off, and dump a file for you. I'm not going to actually do that right now, but I can show you the output in Chrome of one that I ran previously. If I go to the inspector tools, I can actually load a CPU profile that I created that way, and I ran curl against it a whole bunch of times. And if you zoom way in, you can actually see the individual HTTP requests. So you could see there's my basic listener from my script. I know it's a little small, and I did a couple different methods within that basic listener. So it's just a nice way to programmatically access the inspector. I do want to show Node inspect really quickly. So we'll spin that up again. Node inspect is a lot like if you've used Node space debug and then a script.js. You know, it starts up a CLI debugger there, and you can actually attach and set breakpoints and do things in the command line. Node inspect does the same thing for the inspector protocol. So I can say node inspect. You see a whole bunch of stuff just went by over there. I can say set a breakpoint in index.js line 15. and it actually already hit that breakpoint. And it shows me what I got. Actually, this is something that it's right now, Jan Olaf Krems wrote it, and it's not yet in the foundation, and we're discussing how to bring it in and how to make it available. So definitely would be interested in your feedback on that. The last thing I want to show, actually, you know what, I'm going to skip the last thing I would like to show, but I'm going to skip right now on this, is that VS Code and Chrome DevTools, when they connect to debug, are going to use the exact same protocol. And if you would look on this right-hand side where I've got the T-shark trace going, you would see the same things going in and out. And the purpose of all this, the reason why I'm showing you all this is to show that ultimately it's that same interface, it's the same WebSocket protocol, which whether it's the lowest level of WebSockets, whether it's a command line tool over, or whether it's some complex GUI tool, they're all using the same thing, and you can use them too in your tools and in your workflows. Okay, so with that, let's move on to the tracing controller. So Matt Loring and other folks from V8 that I think are in this room did a lot of work on this, and I hope that I represent it decently well. Right now it's a PR. Here are some things about it. First of all, it's the same format as the traces that you can get out of Chromium if you go to Chrome whack tracing and start recording a trace. So it's can be read, for example, in Chrome tracing. You could trace any point in code just by dropping in a macro. It allows you to correlate async events by IDs, and I'm actually going to show you doing that. Something that we need to talk about actually is you can record some dynamic unfixed data, and maybe we can use that to better log information about what's happening in core. I'd be interested in people's feedback on that. Then I put here the things that might come next and things that we need to think about and that we need feedback from the community on. What kinds of things do you want us to trace? Is a JS API, a JavaScript API, because right now it's all in native code. Do we need something like that? So please give us feedback on that. Okay. Don't have that much time, so let me hurry. Basically, the architecture is you put a trace point somewhere in your code. It goes down through the whole tracing controller hierarchy and writes out to a file full of trace objects. Let's just go ahead and do that really quick. So, node 9304. I will say node dash. Oh, I meant to show you, actually, before I do that, the trace points that I've added here. So I've only added about 20 lines into Node Core to track connection wrap. So connection wrap is created when a TCP connection is made from outside into Node. So I'm going to track when that connection is made to when it's torn down, which should give me a rough estimate of how long the request took. So I've dropped in this macro into when the connection wrap is originally created, trace event nestable async begin. And I've dropped a similar one, trace event nestable async end, where it gets destroyed. I've added a couple other things here too. I actually added an ID to every handle so that I can track which ones are getting created and destroyed. So now if I actually run node and I say enable tracing and I run it against my favorite script, index.js, I'll curl against it a couple times. Whew. Fast. An interesting thing about it at this stage is that if you do a Control-C to stop the process, it doesn't actually flush the log properly, so I had to add that whack stop to make it stop gently. Now I'll see in this directory a node trace 1.log. And the best, one way to parse it's just JSON. So one way to parse it is just to go into Node and parse it yourself. I actually wrote a little script so I could show it to you quickly. Scratch process. And let's just grep out for Node. And you can see the logs that I got for Node. We don't have that much time, but you can see I've got the same ID for these two. That's how in Chrome tracing, for example, it maps them together, and you can subtract the second number in this column. This is a timestamp to get how long it took. And one last thing that I'll show, and then I'm going to be done. is I can also load that output in Chrome tracing. So I can say load, I already have copied it over here. There's my log, and you can actually see where it actually is aware that this interface is aware that the connection wrap, the two events are correlated because they share the same ID, and so they both show up here, and you can see other V8 execution stuff happens on top of them. Like an interesting thing here is you can see that the first request took a lot longer than the other ones, et cetera, et cetera. Okay, so let me wrap this up. Some overtime. Recap the diagnostics working group. We want to create open interfaces that everybody can party on, projects, products, your own scripts. Showed you a little bit about Inspector, hopefully gave you an idea of what you can do with it, and Tracing Controller. It's at its early stages, help us determine what we should do with it. And hopefully you learned a little bit about some scripts and tools there. To conclude, here's some resources. You can find this deck. I just uploaded it a few minutes ago to that GitHub repo. And that's it. Thank you very much.